Capacitance of spherical capacitor. So spherical capacitor, what is the spherical capacitor? As I have already explained, there will be a two spherical shells, there will be positive charge at the outer surface of the inner shell, and this will be a spherical, and negative charge on the inner shell of the inner surface of the outer shell. We have to find the capacitance. Yes, where we have to find the capacitance, as I have already done in the case of the point P is anywhere in this. So we have to find the electric field on this point P. Okay. Okay. So as we have already discussed, the field will be a radial and spherical symmetric. As we already explained, electric field intensity will be spherical symmetric due to spherical charge distribution. Due to spherical charge distribution, this charge will be a spherical, electric field will be a spherical. So as in the case of parallel plate, the same as, because so Gaussian surface will be a spherical. Yes, spherical, and that will be a equal potential. Okay. So Gaussian surface will be, must be considered sphere. Okay. So point P must be a, and this will be a equal potential surface. Okay. Capacitor of spherical capacitor. Okay. So Gaussian surface must be considered sphere. Okay. And this will be equal potential surface. So motion will be from, so Gaussian surface is also a sphere. So in this case, the motion will be because this surface is equal potential surface, and the same as the previous case, the motion will be from this sphere to this. Okay. Okay. So delta phi minus, if I say that this point, this is R1 and this is R2. Okay, if this is the radius of second cylinder and this is the radius of first cylinder. Okay, then the R1 to R. So Gaussian surface must be considered a sphere, and P and potential will be vary from A to sorry R1 to R2, because this point P will be anywhere between this S1 and S2. If I say that this is S1 and this is S2, so P will be anywhere between the S1 and S2, because this Gaussian surface will be treated as an equal potential surface. So the change in position on particular orbit uh, will be ignorable, because it have no importance. There will be no change in potential, but potential will be vary from S1 to S2. So we have to consider the motion from R1 radius to R2. Okay, so that's why E1 E D DL, firstly DL. Okay, firstly it will be DL. So this will be a minus E DL. So it become a dr. Yes. Yeah, dl cos theta is equal to dr, as we have already explained in the previous. You may write in this way too, dl cos theta, and this will be a e dr, or you may directly write as we have done in the case of the previous. Okay, so that will be a r1 to r2 or r1 to r. आप इसे इग्नोर भी कर सकते हैं, ये डायरेक्टली लिखना चाहें या ये लिखना चाहें, दैट विल बी okay, but here is minus, sorry, negative. Yes. Okay, so E, yes, electric field at point P. Yes, what is that? Yes, what was the expression for spherical capacitor? Spherical. E was the sigma r square okay, in the case of 4 pi sorry, that was this one for q total, q over 4 pi x naught r 1 square. Yes. Okay, why only r1 square? Actually, this will be due to r1. That's why there will be r1 square. Okay. Sorry, that was not 1 minute. R1, that was if this is R, if this if I say that not if I say this R, that depend upon the radius of this Gaussian surface. If this is R, then that will be R. If that is R1, that will be R1. If that is R2, then that will be R2. That was the different case. So here was a Gaussian surface radius. आप चेक करो वहां लिखा था radius of the Gaussian surface, वहां हमने inner point के why we have taken the R1 here. R1 is the radius of first sphere, here R2 is the radius of second sphere, and in the case of last exercise R was the radius of Gaussian surface. If this R is the radius of Gaussian surface, that was the radius of Gaussian surface, not the radius of shell. Okay, so here we are using the two shell, that is R1 and R2. That's why we will use the R scale. Okay. Okay. So this is reason. Okay. Now the question is, will we have to add or some electric field due to this and this plate? Will we, as we have done in the last case, we added the electric field due to first surface and second surface. Same procedure will be applied on this or not? No, because electric field due to this field, if point is outside, then electric field will be affected. Okay, so there will be electric field only due to this sheet, not this, because this point P is inside the S2. It is not closing this surface S2. Gaussian surface must be closed to find the electric field. Electric field will be zero due to outer charge and not zero due to inner spherical charge. नहीं समझ आया? What is the Q enclosed? Here is Q enclosed. Okay, Q enclosed. Yes, that the charge is enclosed. This surface is only by the S1, not S2. Yes. So that's why only S1 will be considered. Okay. So here goes. Have you got the reason? In the parallel plate capacitor, we have added two electric field due to first plate and second plate. But in this case, we are not adding, because the electric field for closed sphere will be considered only the charge enclosed, not the charge outside. So S2 is not included, since the charge on S2 is outside the this Gaussian surface, so that will be excluded. That's why we must write the charge due to inner surface, sorry, electric field due to charge on inner surface plus electric field due to charge on outer surface. इनर सरफेस की वजह से ठीक है, आउटर सरफेस के लिए जीरो है. यस, तो the short question may be why the electric field due to the, you must note the short question must be may like this: electric field due to charge on outer surface will be a zero. Why we will consider only the charge on due to inner surface? Because the closed surface is including only the charge on S1, not due to S2. Okay, so that's why the charge will not be, when we sum 0 with any number, the result will be the same. So that will be remain the same. So the charge due to the surface S2 will be a 0. Charge electric field due to the surface S1 will be this, and electric field due to the S2, that will be a 0. So that will be the result. Okay, got it? So what will be the delta phi? Yes, that will be equal to, yes, minus q 4 pi epsilon naught r square r1 to r2. Yes, dr. Yes, q is total charge on this sphere, and that will be a constant. Again, that is not changing with respect to time. Oh, sorry, with respect to moving from uh, S1 to S2. Q is the total charge on S1. S1, ठीक है, inner surface, and constant for motion R1 to. Okay, क्योंकि that is the charge on S1, not on the S2 or in between. So the motion from S1 to S2 will not affect on this charge. This charge, total charge, will be remain the constant. So what will be the delta phi? So delta phi will be minus, yes, q will be come out 4 pi epsilon naught, and this will be delta r over r square, r1 to r2. Yes, minus q over. Yes, yes. Uh, function and its derivative, function's power and its derivative, I have already explained. That will be equal to minus q 4 pi epsilon naught r minus 2 plus 1 minus 2 plus 1 r1 to r2. Okay, and this will be equal to minus q 4 pi epsilon naught r minus 1 minus this minus 1, this minus will be cancelled with this minus. So what will be the result? Delta phi will be equal to q over 4 pi epsilon naught, because this minus will be cancelled with this minus, and that become 1 over r, r1 to r. Okay, and we may write 4 pi epsilon naught 1 by r2 minus 1 by. Okay, got it. And c will be q over delta phi q divided by q 1 by r2 minus 1 by R1 4 pi. No, this q will be cancelled with this. Okay, so this will be the capacitance of the capacitor due to spherical capacity. Now, the short, what type of the short question may be appear in the papers or midterm exams or in the quizzes related to this topic? Why we are considering only the charge? Why we are considering only the charge due to S1 to find the electric field at point P? Why that is 0? Okay. Why we are not considering? Why that will be 0? What will be the charge on the outer surface? What will be the electric field due to outer surface? What will be the electric field due to the inner surface? And such kind of the short question may be appeared on the in the your quiz or midterm. Okay, so this is the electric field intensity.